Please show me that you are on the right page. Turn your iPads my way. I want to make sure I know who's with me and who's getting there but not there. A loading screen is fine. Okay, good. Then, didn't we just do combinations? Yeah, but now we're going to do them much deeper. Combinations are for when order doesn't matter. Like, for instance, if you're going to be picking a committee, that's a key word. Because in committees, it's not like there's your first, your second, your third, your fourth. Now let's rearrange you. You're just a committee of 4 people that are like trying to work out a problem or whatever. You don't, not everything has to have order. But if I do say arrange, a lot of people don't catch that that would mean that the order would matter. Like, for instance, my Kleenex boxes. Okay, if I have my Kleenex boxes here and I want to arrange them, that implies in order, in a certain order, so that, for instance, orange yellow is different than yellow orange. Okay, so arrange would be a permutation. So watch out for just does order matter or not. That's the first thing you have to decide. I'll give you this clue on the ones we're doing today, which is food. Usually the order doesn't matter. You're like really a strange person if you say pizza, I have to have my pepperoni first before you put on the sausage. Okay? Now there are people who can always, there's always somebody who's the exception to the rule, right? How about card games? Well, there is actually card games where the order that the cards come out matters, but for picking, think of it this way. When I hand you your cards, usually it's about the hand you pick up. Usually you don't pick it up and it's in a certain special order. You just pick it up and you rearrange it to be whatever you want it to be. So the order doesn't matter when you got those 5 cards. If you got 5 cards, we're going to say order doesn't matter. If order doesn't matter, is it a P or a C? C. Okay. Then yesterday I taught you how to actually compute them by hand. Let's see if you actually have a short-term memory. 5, C, 4. That's the more complicated kind because it's got an extra kicker somewhere. See if you remember how to do this with factorials. The answer is something you can do, like you can actually multiply it out and say the answer is 68. Figure out exactly how many combinations this would be, and I'll give you a real-world context. There's 5 people, and only 4 of them can be on the committee. 5, choose 4. Don't use a calculator. Use the factorial thing. I'll give you this hint. 5 times 4 times 3 times 2 times 1 is in the problem. All right, I'm going to pause for a second. Okay, let's see if you remember this properly. You should have said 5 factorial. Over 5 minus 4 makes 1 factorial, which is just 1. Is that it? No. See, there's an extra 4 right there. Raise your hand if you knew there was a 4 factorial there. Good. And then a lot of stuff cancels. I'll write it out for the people that don't really understand. 5 times 4 times 3 times 2 times 1 over 1 times 4 times 3 times 2 times 1. That cancels that. It's just 5. So if you have 5 people and you're making groups of 4, you could make 5 different groups of 4. So that's a C problem done by hand. Okay, here's another one done by hand. A, P, R. Would you please figure out what that one is? And notice it's a P this time, not a C. And you'd have A factorial over A minus R parentheses factorial. Raise your hand if you had that one right. Awesome. Then let's move on to the new stuff. So I'm going to get to the actual file for today. It's about Chipotle. Hey, if I actually had all of you, this would be a fun field trip just because, like, we've been talking about permutations. We have to go to Chipotle. So we all get in the van. Of course, we can have all the different ways we'd arrange that. And then you get to Chipotle, and then you actually get all your different arrangements of food on your burrito. There would be a ton. In fact, I would bet that in this classroom, unless you like coordinated with each other, there'd only be a few kids that would get the same exact one. All right? I would like you for right now to just, without any rules about what it has to be like, this or that, if we were at Chipotle and these toppings were being considered, I would like you to circle what would be on yours. Circle the things that would be on yours. And if there's anything that's slightly different than somebody else, then it's different. Yes? Okay, I just said to circle what would be on yours. You can handle that. I just saying to circle what's going to be on yours. Do you think I'm going to make you? You must take beans. I didn't say that. I understand, but I made it really simple. All right. So now, let's see if anybody had this combo. White rice with pinto beans, chicken, and guacamole, and cheese, and corn. Raise your hand if you had that combo. See? This is an example. Okay, so I'll call a random person and see if anybody has theirs. The point is, there's lots of different combinations. Notice I'm not caring about the order. You know what I mean? Oh, you put your cheese on before I did. No, that doesn't matter. The order doesn't matter. Okay, row one, last person actually. So tell us what yours was. Brown rice. Okay, how many of you still with her at brown rice? Okay, there's 4 or 5 people left. Okay, keep going. Anybody else have brown rice and pinto beans? Oh, 2 people. Or one person still with you. And then? No meat. Anybody still with her? Okay, end of story. Okay, so let's try a bit of in person here. This is row 2, person 5. That'll just make you last person. All right, who's still with him on the white rice? All right, and then keep going. No beans, who's still with him? Okay, a lot of people. Keep going. Steak, who's still with him on the steak? All right, now we're down to 3. Keep going. Guac. What is that? What's that one funny meme about the guacamole? Oh, fresh avocado, yes. All right, anyway, keep going. Cheese. Anybody have that exact one? Nobody. All right, so my point is, why would you? Because there are a ton of combinations, and the probability is pretty small, isn't it? If there are, let's say there are 600 different combinations, then what's the probability you'll be the same as him? Well, 1 that he has out of 600. There's only 1 in 600 chance. See what I mean? So it's not likely you guys are going to have the same one. Now, I will say, there are some things about this that are not random. Think about that. Do you get that there are some ingredients that just are kind of like you? Not many people like those. So then we know that the probability of that is actually lower. Like cheese, I'm guessing, is fairly high. How many of you had cheese on yours? Okay, see, almost everybody. Wisconsin would be very happy right now. All right, so anyway. Now let's actually do some problems, and it's important for you to understand when. Here, let me stop for a moment and make sure you get this. If I say something like this, 5C2, that's like I had 5 things to choose from, and I picked 2 of them. Do you get that? Okay. Now, what if I had 5 things to pick from, and I picked 2 of them? That sounds like, those are all the like optional things that you could put on, like guac or put chips on them. Guac or cheese or sour cream or the salsas or that kind of stuff at the end, right? But at the beginning, didn't you get a choice of whether you wanted the bowl or not? How many of you actually chose bowl? All right, it's quite a few of you would pick the bowl option. If you want to do it where you get the most, did that little math behind it. They will tend to fill up the bowl more, and then you can always ask for the shell inside. They won't charge you for it. I've double-checked that twice since I did that presentation with you guys. Chipotle, thank you, gave me a free one yesterday. Although you have to buy one, but it was a buy one get one free for teachers on Tuesday. So anyway, okay, back to if this is my veggie kind of choices. Do you get if I had 6 different kinds of meat, which actually there is, except one of them is the meatless option. See that, and you chose that one, right? Okay, so there's a no meat option too, and that's one of the 6 choices. And you usually only get to pick 1 meat, right? They'll charge you extra if you choose more than one meat, unless you ask for half and half. And again, that happens so rarely that they'll tend to give you 40% more meat if you go that way. But they will charge you for the more expensive meat. So find the two cheapest meats, and then if you really want to make this the cheapest deal. All right, so anyway, and what do you think happens between those C's? You multiply choices. There's almost never a time where you will ever add things. You will be multiplying choices. Just like when we had things in the wardrobe, I have 6 pairs of pants, I have 10 shirts, I have 2 pairs of shoes. You just multiply all your choices. You're always multiplying. So you're multiplying your C's. So you really just have to decide for these problems today whether it's going to be just one C, like there's 52 cards in the deck of cards and there's only one, no, there's actually 2 jokers. So if I'm going to pull out 2 cards, how many different combinations could I get? 52, choose 2. That's just a solo C. Or if your thing was broken into parts, like here's the meats, here's the vegetables, here's whether you want a shell or a bowl, you know, there's 2 options for that. If you have separate choices, you multiply the choices. And then the last kind that we're going to talk about is CC over C. I'll give you an example of that one. There's 52 cards in the deck of cards. And let's say I'm going to deal you 5 of them. Then what it's out of is there are millions of possible hands that I could deal you. Okay, if I had a deck of cards and I deal you 5 cards, there's millions of different combinations where order doesn't matter. There would be multi-millions of permutations, as in if we cared what order I handed you the cards in. Okay, so anyway, then let's say I did this as diamonds and not diamonds. How many diamonds are there in the deck? Somebody's going to have that memorized. 13, very good. And how many not diamonds are there? Well, this is the total, so you could do it in your head. It's kind of tough, though. It's 39. 13 times 3, very good. Okay. Then, let's say I want what's called a flush. That's where you get 5 of the same kind, like 5 diamonds, for example. Okay, if I wanted 5 diamonds, then that would mean I'd have to have no not diamonds. I want you to process what I just did there. There's 13 diamonds out there, and then 39 that are not diamonds. That's a total of 52. Notice those add up. Anybody ever been in chemistry where you have to balance equations? All right, this is not nearly that hard, but it will balance. Then 5 and 0 together make a total of 5. If any of that didn't add up, I must not have done it right. This is the toughest kind. I'll give you another example like that. How many of you guys play Texas Hold'em? If you know what I'm talking about, raise your hand. All right, so there's 5 of you. You get dealt 2 cards. Tell me, what's on the bottom? 52 cards, because you get 2 cards in the deck. Choosing out how many? 2. You get dealt 2 cards. What is the best card you can get? An ace. And in fact, the ultimate would be to get 2 aces. Double aces, yes. Sometimes called pocket aces. Pocket rockets is another way I've heard it described. So if this is aces, and this is what? What am I going to write there? Not aces. How many aces are there in the deck? 4. How many of them do you want? 2. Get what I'm doing here? And then how many not aces are there in the deck? 48. Because if you weren't going to get that number, you were like, where are they getting that number? This plus this has to make this, right? So that's why it has to be 48. Okay, and then there's 48 not aces. How many of those do you want? 0. And when you choose 0, automatically the answer is 1. It may seem like the answer is 0, but then if it was 0, the whole top would cancel, right? So this is equal to 1. This is a number. You could calculate it in your head. 4 factorial over 4 minus 2 is 2 factorial. On C, it's a C problem, so there's an extra 2 down here. Extra one of those. 2 factorial. I could do that all in my head if I wanted to. That one I would not want to have to do in my head, because that's a big number. It's huge. All right. So, moral of the story, that's the hardest kind. And you already learned it. All right. So let's go back to the Chipotle question and show you what I mean. If you were able to choose any toppings, well, we added them up in a different hour, and there's 18 choices up there. I know, we normally break them up into little, like, how many of these do you want? How many of those do you want? How many of these do you want? But if you just put them all together and they say there's 18 things, there are people that will just say, I just want meat and cheese, and that's it. Did you know that you can actually ask them for a, what's that thing where you have just cheese melted in a shell, a quesadilla? And they're pretty cheap, because it's cheap for them too, right? The taco shells are probably like a dime, and then a little bit of cheese, but they sell them, they're pretty cheap. And if you want, you can add some chicken to it, and it makes actually really good. Just chicken and cheese and the soft shell thing. Mike will get that today. All right, so anyway, 18, C, and then 3. You get to choose 3. That's all there is to this one. All of the toppings are lumped together into one thing. But on the next problem, they break it into one type of rice, beans. No, one type of rice. This is worded kind of badly. One type of rice, one type of beans. I mean, most people just pick one of the 2 kinds of beans. You can ask for both, and they will give you a full serving of both. If you're going for that, like, biggest one, you just ask for both. Ask for both kinds of rice. They don't care because they're so cheap. They just give you a full serving of both. Anyway, we want one of these. Oh, wait, that doesn't even say a thing. One of these, we want one of these, and we want one of these. And again, I recommend you actually ask for half and half on the meat because you get more, 40% more. Then 3 other toppings, 3 of those, and then 2 of these. So how do we break this up? It's a whole bunch of C's. C, 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 and C. C. Okay. So on the rices, how many were there? 2. How many are you going to pick? 1. On the beans, how many were there? 2. How many are you going to pick? 1. And on the meats, how many were there? I'll tell it, save you some time. There was 6. How many are you going to pick? 1. And I know you could do half and half, but that gets complicated, so we'll just say 1. Other toppings? Other toppings is right here. I've forgotten how many there were. 1, 2, 3, 4 things. I know in the real world there's actually more than that, but we'll go with 4. And I get to choose how many? 3. And then lastly is salsas. How many salsas are there? 1, 2, 3, 4 salsas, and I'm going to choose 2. And don't forget, what do you do with choices? Been saying this since day 1. Multiply choices. There are weird cases where you add, and it usually involves the word or. Like, I'd be fine with this burrito or that burrito, and then you could say there's this many plus that many. Okay, so if you're going to say or, that can involve an add, but it's rare. Always default to multiply if you're not sure. Okay, this is easy. Choose 1. If I have 2 things, and I'm going to choose one of them, how many ways is there to do that? I could either choose this, or I could choose that. There's 2. So that's 2. That's 2. 6, choose 1. Okay, there's 6 things, and I'm choosing 1 at a time. That's pretty easy. 6. 4, choosing 3. Okay, now that's a little more icky, because then you got all these like rearrangements and stuff. So if I had to do this in my head, I'd go 4 factorial over 4 minus 3 is 1 factorial with an extra 3 factorial. And then I could do that pretty quick in my head and go, oh, it's just 4. That one's 4. 4. And then the last one is 4, choose 2. If I had to do it in my head, 4 factorial over 4 minus 2 is 2 factorial with an extra one of these, C, because it's a C problem. And then that's 4 is 3 times 2 is, so that'll be 6. I did it in my head, yay. You will have a calculator for most of this test, but there are parts where they say, show how you could do this without a calculator. So that's 4, that's 6, this is 6, this is 2, this is 2. Times them all together, and you got your final answer. Let me see if I can do it in my head. 4 times 6 is 24 times 4. That's going to be 80, 96, and then I'm going to times that by 6. Okay, now, I like to do it this way. 6 times 6 is 36, carry the 3. 9 times 6, 54, 57, 576 different burritos. Do you get why, if I picked him, for instance, that probably nobody else has the same as him? Because there's 576 different things you guys could have picked. All right. Now, granted, there is some higher probabilities. If I say, like I said, cheese, there is a higher probability of that. But on the meats, there's a wide variety of what people have. Just a lot of people pick chicken. How many pick chicken? All right. How many pick the carnitas? A lot of those too. Did anybody in here go for barbacoa last hour? No, no barbacoas. I was really sad. That's my favorite personally. I love the barbacoa. It's got a little bit of spicy. You gotta handle spicy. All right. Okay, let's move on to the next. So there we go. This one seems like it's going to be super simple. Oh, there's 35 people, and I get to pick 3. 35, choose 3. I will tell you that is the wrong answer. Figure out why that could not be right, and then tell me what the right answer is. Don't say it, write it. Some people haven't even read it yet, so I don't want the answer yet. Just let people think. Pause for a second while you think. So, back to this. Sorry, I was just told that I hadn't. Okay, we'll talk later. You can be included too. This 32 choose 3 was there because there were 3 people that couldn't be in the choices this year because they were on it last year. All right, moving on. Now let's get back to this one. 2 chocolate chip cookies. You got to read the question. There are 6 chocolate chip cookies, but out of what? And a lot of kids just want to do this as okay, there's 6 chocolate chip cookies out of a total of 18 cookies or whatever. What is it actually? Anybody added it up yet? 14? Anybody verify 14? Okay. I'm double checking that. 6, 5 is 11. 12. This one's 2 cookies at random. That's not random cookies. Okay, so 12. So a lot of people want to say 6 out of 12. No, this is much more complicated than that. Because you want 2 chocolate chip cookies, and there's all these different combos you might get. You got to act like he's doing this in the dark or something, because he can't tell, and hopefully he's not going to like feel the cookies and go, ooh, that feels like peanut butter. I'll take that one. Anyway, he just reaches in and takes 2. He doesn't know what he's going to get. There's a lot of combinations. Get the C thing? And so this is a CCC thing. Why isn't it an over C? Because it's not a probability. If it's probability, you divide by what was possible. This is just a CCC. What are the 3 C's? They are chocolate chip, peanut butter, and oatmeal. Oat. How many chocolate chip were there? 6. How many do we want him to choose? 2 times how many peanut butter were there? 5. How many do we want him to choose? 0. And lastly, times how many oatmeals? 1. How many do we want him to choose? 0. There we go. That's it. Does it say probability? Oh, dang, you got me? That's how many possibles there are. No, that's not what's possible. That's what we wanted to happen, right? So thank you for catching that. That's what we want, and doesn't the want go on top? Over what was possible. There were how many total cookies in there? 12. Choose, how many were we going to pick out? 2. And do you remember me saying that these would balance, like you were sort of balancing an equation? That has to add up to that. Does it? It does. And this is supposed to add up to this. Does it? Yes, so I did it right. I have almost never seen a kid where if those balance, that they got it wrong. So just check and see if yours is balancing. Not, again, that's a causation correlation thing. You could force it to balance but not be even understanding it. But if you look at yours, you think you've got it, and it doesn't balance, you know you're wrong. All right. Would you please do the bottom one? It's very similar to the top one. It's a CCC over C thing. Just the numbers are slightly different because you only want 1 chocolate chip and 1 peanut butter. I'll pause while you try that one. Let's see how you did. I'm going to do chocolate chip first. In that scenario, there are 6 of them, and I want how many of them? 1. Always times your choices. On the peanut butters, there were 5 of them, and I want 1 of them. And you don't have to include this last one. I really encourage you to do it on the oatmeal. I know you're thinking, but he doesn't even eat any oatmeal. But if you don't include this one, it won't balance. And as we all know, it's always good to have balance in the force. That plus that plus that should make that, and that plus that plus that should make that. Did it balance? How many of you had the same thing as I had? All right. And it's right. Okay. So that's a CC over C kind of question. This is where it's probability. How would it have been different if I had answered without this? It would have been a number of ways it could happen. A number of ways you could get 1 chocolate chip and 1 peanut butter. Okay, this is not all the things that could happen. If I wanted all the things that could happen, that's the bottom part. When he takes the cookies, wait a minute. I've done something terrible. Where is it? Oh, I've lost it. I'm not going to even try to find it. I'm giving up now. The thing on the bottom, the C on the bottom, that was all the things that could have happened when he took 2 things. All right, so that's kind of like this one. What are all the things that could happen when you get 5 cards dealt to you? You got to know how many cards are in a deck, so I'll tell you. 52 cards in the deck. So 52 what? C, 5. I want you to see that one. Grab your calculator if you haven't already, because you need it for your homework tonight anyway. And see what you get. Notice this is if the order doesn't matter. It will be way bigger if the order mattered and it was a P. You pick up your 5 cards and you look at them all at once, then the order didn't matter. Need to borrow one? Need to use the bathroom? Go ahead. Need to borrow a calculator? Please do. I've got them up here. You just have to leave me some collateral. It's okay. Somebody must have it by now. What'd you get, FK? 259 8960. There is over 2.5 million hands. So if I dealt you and you were looking for a certain hand, it didn't even matter the order. If you just wanted, like, I don't know, ace, king, queen, jack, 10, that would be a royal straight. If they were all the same kind, it would be a flush. If they were like all clubs, then it'd be a flush. Anyway, so ace, king, queen, jack, 10. I was waiting for that one hand. Well, there's 2 million hands possible. You could be dealt, like, all the cards I've ever played in my whole life. There's no way it's even close to added up to 2 million hands being dealt out. So you could play cards for a long time and never get one of those awesome hands. I did actually get a straight flush once. After tons of hands being dealt, I got a straight flush. And anyway, that means you got like 5, 6, 7, 8, 9, and they're all the same suit. That's only happened to me once in my whole life. Tough to get. All right. Find the number of 5 card hands with 4 hearts and 1 diamond. Did they ever say the word probability? No, then I'm not dividing by anything. So it's just a CC thing. And it's just a matter of how many C's I have. 4 hearts and 1 diamond. This is hearts. This is diamonds. And hint, this is everything else. Technically, you don't have to have that. But I like this category of the other cards. There's hearts, there's diamonds, and then there's the other cards. How many hearts are there? That's the first question you can always ask yourself. 13. How many diamonds are there? 13. How many other cards are there? 26. What do you do with choices? You multiply them. There's only one little thing left to do. Other than that, see how the setup worked? You just have, you know it's a bunch of C's, because it's not a probability. You don't have to divide by a C. Now it's just fill in these 3 numbers. So, how many hearts did we want? 4. How many diamonds did we want? 1. How many other cards did we want? 0. Now, again, I would have allowed you to not include this last one. Why? Because it just equals 1. And timesing it by 1 won't change your answer. But it brings balance. It's like all the other things should have their own little category. Not required, but smart. Especially because when you do this kind, over 52, choose, how many cards do we have? 5. Then we can find the probability we got that hand. You need this for stuff to balance. Okay, I think I've said too much. I'm quoting songs today. So, that is your homework, and I have decided a way to shorten it because there's a big beast problem in the middle. I think it's problem 3. So I'm going to just say, you may avoid it and do everything else. 1, 2, and 4 are what I want you to do. You may skip number 3. All right, that's all I have for you for today.